Good morning, friends. Am I visible and audible to you?
Yes, sir. Morning, sir.
Perfect. Perfect. A very good morning to you once again. So you got a chance to go through the deck that I shared last night
Yes,
for
sir. We received the
this
PPT,
practice
sir.
and discuss? Perfect. 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 What I can do is that let me do a quick recapitulation what I taught in the last class, and then I can take the questions you have any, and then subsequently I gave you a food for thought. I can take your thoughts. Please try to be on time. Those who are coming late. Yeah. So let's start with the quick recapitulation. I think that's all. No more entry. So we discussed yesterday why retention analytics matter. I don't think there is anything, rocket science here that I need to discuss it once again. It's simple business logic. This is something what may sound very interesting to you, but because you are not much exposed to the concept of how to design a solution, how to develop a solution framework. So that's something interesting to you, I guess. You also got a chance to see how the solution framework for churn analytics gets developed. And with that note, I gave you a food for thought regarding the Lenovo churn, how you can do it. And in this slide, I walked you through how the different approaches can be there even for solving one step. That is for the first step only, there can be three approaches. There can be multiple approaches. I have shown here three. There can be 30 approaches as well. And for each approach, there can be multiple algorithms. I've also discussed the concept of model comparison. That means all the applicable models should be applied, and the model that's the best fit or the most fit model would be deployed in the production environment. And I also discussed that to develop every model, we do more than 100 iterations. So it's not just mathematics where you solve an equation x equals to 3, y equals to 4. It is not like that in machine learning. Given the fact that you already know the basics or the fundamentals of machine learning, you must be knowing that there's a feedback loop. Through the feedback loop, we continuously train the model. Keep training the model. That's a better way to express. Retrain the model, retrain the model. That's the iteration. And with every iteration, the predictability of the model, the predictive power of the model, the accuracy of the model increases. Am I clear? Any question, any thoughts to not only what I said now, but what I taught in the last class? Any questions, any thoughts? Any of you, any questions? Okay, I assume there are no questions and everybody is clear. So yeah, I gave a food for thought yesterday. So please come up. You would like to share your screen. I can stop sharing. You can present a quick slide of your solution. Who would like to volunteer? Have you thought over it? Have you thought about the problem? I said, uh, am I audible to you? Yes, no?
Yes, sir. You audible.
Okay. So may I expect any answer from any of you? It seems that none of you have thought through. What's the reason, may I know? Like lack of time or lack of interest, lack of understanding? This is something not in the best interest of the class. Or the simple reason is that if there is no response, then there would be lack of two-way communication. And with the lack of two-way communication, there would be a monologue. Monologue means I shall only speak. I cannot understand. That won't be any feedback loop. I cannot understand whether you are understanding, whether your thought process is evolving in the way I anticipate. Any of you got a chance? None of you. It's really surprising. It's very surprising. Out of how many students are there? Today, 34 students joined, and yesterday it was more than 40, 45 or so. For the last time, let me ask, any of you got a chance to think through it? How can you solve a churn problem? Would you please let me know? At least I understand you have not thought through, but would you please let me know where you are lacking? That means you don't have a practice to think, or lack of understanding, you have not understood the concept. You can ask me in that case. This is not something a big homework.
So we are understanding, but the thing is, we are not able to understand how logistic regression or any other regression is working and helping the churn rate, reducing the
But
churn
that
rate.
was not the ask. That was not the question that was asked. That's absolutely fine. You are not supposed to understand this stage because I have not taught you that thing, right? I have not taught you. So that was not the ask also. The ask was, can you design a solution framework? For developing the solution framework, what is required is a logical thinking. Say, for instance, is that I have shown you this slide. Do you think any part logistic regression was mentioned, or any of the statistical techniques I clarified? I mentioned that thing also a number of times. That was not required. You did not know any of the techniques at this stage. So what happens, if I start teaching you the statistical techniques from the very first class, those who cannot cope up, it cannot happen that everybody will have the same capacity. Those who cannot cope up the mathematics, the interest will go down from the very first day. So have patience. We will come to the statistics part at a later stage. Right now, you have at least the logical thinking clarity, which everyone can have, irrespective of their background of arts, science, commerce, engineering. So that cannot be an excuse that I don't know logistic regression. That's why I cannot develop a solution framework. Precisely, that cannot be an excuse. In the interest of time, of course, I shall move on. But that's not something I expect going forward. Whatever I ask, don't consider it as a kind of formal homework I'm giving. But whatever I am telling you to think through, mostly I shall tell you in this way. You think through the problem and share your thoughts. That's absolutely for your betterment. Absolutely. Not a kind of requirement of marks, not a requirement of any formalities. It is just, if you think through it, your thought process will be evolved. As simple as that. Okay, so let me do in this way. In fact, I developed I have done the homework. So if you can see my screen, you can see that this can be another solution framework. So what kind of solution framework is this? First, we will develop the association rules. Those who don't know what the association rules are, a simple application is a kind of market basket analysis. That means if a customer purchases product A, what is the probability of the customer purchasing product B? Those are the different kind of associations we generate. And that happens through multiple data mining algorithms. And there are these algorithms are called association rules or a priori algorithm like that. So First, we can do a kind of data mining for relationship extraction to figure out, has the customer purchased whenever there was a promotion, or customer has got some coupon? That's a kind of conditional purchase. Is there a kind of time gap? Only after the expiry of the 2 years, 2.5 years, or 3 years, customers purchase laptop. Is there any purchase pattern and the points accumulated? Is there a kind of similarity? Once the points get accumulated, customers redeem that and then they purchase. Is there any kind of membership days and purchase pattern? Is there that kind of rules exist? So that's the kind of association rules first we can mine. Then we can do some kind of segmentation. What these algorithms are, you can ignore it for the time being. We will again come back to it maybe in the next class when we'll do for the customer acquisition part. But at least you can understand that customer segmentation is important. Why it is important? Any of you tell me. Again, it will be a monologue. Then I hate lecturing. I hate lecturing. I appreciate discussion. Why segmentation is important? Share your thoughts. Forget about these algorithms, doesn't matter. It can be any damn thing. But why segmentation is important for this churn analytics?
To serve the customer in a better way.
That's a general answer.
So, how about if allocating the effective resources and maximization of cross-selling opportunities to retain customers?
You were not wrong, but then all these answers are not wrong. But then I gave you a condition to my question. My question, listen carefully, why customer segmentation is important for churn analytics here. And you are not wrong, the second person especially, that was slightly more focused than the first answer. And please mention your names whenever you were saying, that's important for me. Who was the first person who responded?
Sir Akriti.
Akriti, thank you. And second person, please.
Sir Aishwarya.
Yes, Aishwarya. Okay. None of you were wrong. But then you have to understand, we are doing it before any kind of churn analytics model development. Are you understanding? That's something, a big clue I'm giving to you. It's a big clue. It's a huge clue. I'm doing segmentation even before, though in the context of churn analytics, but even before, even before I develop any churn analytics model. Somebody said a few minutes back, logistic regression, whatsoever it is, even before that will come at this stage or this stage, the later stage. But why? Any thoughts? Think through it. Why should I segment even before I do any kind of churn analytics?
So, to find the different strategies for different factors and segments, like in cluster, we can find that there's common patterns are formed in common thing, like in clusters. So we can make different clusters. We can make different strategies for these.
Your name, please.
Kriti Kumari.
Hi, Kriti. Would you
Hello.
please throw some light on, in the context of say Lenovo laptops or any laptop? It can be Dell also, it can be HP also.
So, like in the context of selling a laptop, we can make a cluster. Like in cluster, we can find like in the form of people, like
Of
the
course,
age
goes
of the
without.
customers. In the age of customers, so old people basically will a cluster will form that they will like the laptop with the proper functioning and basic things, and the youngsters will go for the more of the updated softwares, and they will focus on more. So we can have the different strategies for product and
Not
improvisation or
bad,
something.
not bad, not bad. But though demographic segmentation is something which is kind of passive,
Oh.
Especially in today's era. You will find a 50-year-old person is as tech savvy as a 20-year-old guy, quite possible. It was not there 10 years back. It was not there 20 years back. What is more important is two things, especially in case of laptop. What you mentioned, demographic, I would straight away translate that to psychographic. That is a straight away translation. So yeah, yeah, that's a kind of, stereotyping is not something holds true. Like only a 20-year-old guy is passionate about gaming and a 50-year-old is not. Yeah, it is not absurd what you are saying, true. It definitely holds some amount of truth, but psychographic is a better way. That straight away catches instead of demographic is a better fit. What is more important? What is more important in this kind of segmentation is that what for customers are purchasing. Are you a business customer? Then your laptop requirements are different. Or you are a kind of gaming professional. Your laptop requirements are very different. Or you are a graphic professional. Your laptop requirements are different. Or you are a kind of for your personal use for browsing and social media. Which are different. And actually, you must have seen that the different series being generated by the different companies, for all the companies for that matter, they all focus on the usage, right? All the configuration specifications vary with the kind of usage laptop is going to serve. Am I making sense?
Yes, sir.
Yes, sir.
Okay. Now, so that part is clear. Now you bridge the gap. Why this predicament, why this premise in the thought process is important for churn? Now again, I'm coming back to the basic question. This predicament has been established. Why segmentation? Now bridge the gap, connect. Quick, very fast. It's not a very difficult question. Quick, any of you, feel free. There's nothing right or wrong. Let's discuss. Then only I can understand what you are thinking. And thinking.
Hello,
Yeah,
sir.
yeah. Your name?
Yeah, Aman here, sir.
Hey, Aman. Go ahead.
Yeah, so as you mentioned about segmentation, like on the
Mhm.
basis of psychographic, and all the customers have their different
Usage.
requirement.
Yeah,
Yeah, so I think to bridge that gap of churn,
yeah,
see,
yeah.
this kind of segmentation actually help a company to reduce the churn rate
Mm-hmm.
because customer will be very much involved with your company, and they will not leave your company and go. Suppose if I take an example of a uh, not a gamer or not a gamer or a business professional, but
Mm-hmm.
but but a student.
Mm-hmm.
So
Mm-hmm.
usually a student prefers mostly a HP laptop or something. So HP or Dell laptop,
Let's come
which
to a kind of one company only. It can be any company, and within that, let's a different series as per the usage. Yeah. Go ahead.
yeah. So HP laptop,
Mhm.
that is mainly being preferred by the students.
Okay.
So that will actually ultimately reduce the churn rate of HP, because the student will always prefer to go for HP because he's more satisfied with
No,
it.
no, it's not like that. It's not like that. HP has got different series like HP Elite or so on and so forth, and then every
Yeah,
series are being focused to the different usage pattern. But that's not the connect you are establishing. No, HP for student is not the right connect. Let me, in the interest of time, let me give you an answer. The answer is like what I wanted. I expected you to think more deeply. That was my expectation. Coming back to the answer, as the usage varies from segment to segment, rather, I can put it the other way. The segments can be created based on the usage. Their usage pattern will vary. Their purchase pattern will vary. That means what? That means what? They are going to replace their old laptops in a particular pattern. Say the person who are using the laptop for though it is primarily done by workstations, not in laptops, but say somebody is in analytics like me or AI like me, and for any professionals for that matter, and they all work in the high specs. if a new processor comes, which is absolutely faster, and that's from 16 GB, it is offering some 32 GB in a laptop with some high-end processors, high-end or high-power hard disk capabilities. It can not only the terabytes of data, it can have the petabytes or zettabytes of data. It has the capacity to store, to process fast. Then naturally, those groups will try to replace the laptop, the existing laptops, existing workstations. And at that time, they shouldn't go to the other competitors. So if some other competitors are bringing such kind of configurations, you have to be very sure that those guys are not leaving you. So that's the way you can prevent the churn. That means what? For every segment, you have to understand the usage pattern, purchase pattern, when they are planning to replace. For some segment, the churn time is 3 years. For some segment, it is 2 years. For some segment, it is 1.5 years. That's why segmentation is required. If you know that at which duration, what's the right time for each of the segments, they replace or change or update their laptops, then it will be easier for you to apply the preventive measures. Am I making sense? Is the connect clear? Any doubt, any questions, any thoughts?
Clear, sir.
Yes, sir, it's clear.
Great, great. I'm not going to these parts because, of course, we will subsequently discuss all these things. But again, I'm not going to teach you this thing in any way, but you should always keep in mind that how should my consumer, if you are developing analytics models, how should my consumer, that means the business guys, business users, consume my model? How will they use my model? There should be a front end, right? Those who are not from computer science background, don't get confused by this word front end. Front end simply means any kind of user interface which is very easy to use, whatever the apps you are getting, right? Or the apps have got a beautiful front end. So that even if you are a non-technical person, you can just punch in the figures and you will get the desired results. So that's the kind of app you can develop in the front end, or any kind of visualization layer. If you are exposed with the term data visualization, you can use Tableau or any other software for that matter to visualize what you are generating at the back end. So what may happen is that, what I want to mean by app development, if you just punch in a few figures that the customer is a kind of business user, a customer has purchased the laptop in 2018 December, and this customer's company's turnover is this many $1 million or this many $1 billion. If you're giving this kind of independent variables figures, then the app can straight away tell you, hey, this is the time you should promote. You should start promoting because they are going to replace the laptops, their entire system in the next 3 months. Are you all getting the utility of having a kind of app at the front end, at the algorithm at the back end? Both are very important, by the way.
Yes,
Though in an analytics course, nobody is going to teach you how to develop an app. Though I don't mind, I can teach you in a separate class, maybe not an entire class, maybe half an hour, 15-20 minutes, how to develop an app, what kind of technologies we use, because these are kind of bread and butter. We cannot just develop any algorithm and then we cannot give it to customer. Customer will not do anything with the Python code or R code. That is absolutely Hebrew and Greek to any business guy. We have to make it very simple, and customers do appreciate how simple the interface is, how user friendly the interface is. The more the it is user friendly, the easier for the customer to use it, not only by one guy but across the organization. So that's the kind of very important part. Don't ignore this front end part, because primarily all the classes are focused on the back end. For that is a reason, of course. The reason is that this is more of a kind of in MBA school this has been taught, whereas this has been taught in a kind of computer science course. But I think computer science guys also need to know something about the analytics engine, whereas this analytics engine also needs to have some idea not completely app development idea, but some idea about this part, the front end part. So yeah, back end and front end are just like the two hands, simple, or two wings of a bird to make it fly. Okay, coming back to the discussion where we were. So I guess, before I come back, I guess the solution framework development is very clear to you, right? That is something you have to work day in and day out. If you cannot develop a solution, then problem will be you will just be a kind of analyst. Analyst means who will just call a library and apply these algorithms like what is logistic regression, this and this is the lowest rung. Hope you can understood this part. You understand the rungs like the hierarchy. So from here it comes approach. From approach is the algorithm. So that's the lowest rung. So let's start with this one. I discussed what is Churner profile in non-churn database. With this respect, I have given a couple of algorithms here: K-nearest neighbor, LSH, and I shall briefly discuss each of them, though certain things are already known to you, like these things are known to you mentioned. Let's start with the K-nearest neighbor. Do you know what this animal is, what this stuff is, or should I explain you thoroughly? Has it been taught to you earlier by any professors? Accordingly, I shall model it, my teaching. No, okay, no worries. So what is this? It is about I am trying to figure out that how closely, or see if I have to figure out that I need to classify this new example. With whom should I classify? Is this somebody of this class, which are the kind of blue squares, or somebody of the red triangle? Those kind of problems. And how it is important in the churn analytics is the kind of customer which is in question. Are they a part of the churned customers? That means they are showing the symptoms. Are they close? Is the kind of distance metric. I shall discuss that subsequently. Are they close? Suppose these blue squares are the kind of churned customers, for example. So the symptoms or the signals emitted by these customers, is it close to somewhere by the churned customers? That's the question. That's what these algorithms try to figure out. The algorithm looks to the customer database who are most like customers. It's a kind of, we call it kind of lookalike modeling. There are a number of lookalike modeling. So the next one is like LSH technique is also a lookalike modeling, but generally not been used in this context. What do I mean by this context? Where there you have got the quantitative data. There are many examples because LSH is those who are coming from the computer science background. This hashing distance is primarily being used in a computer science, and many of the data, especially in the telecom industry, the telecom data, the telecom signals, in many of the industry, you will find that the data are not exactly the quantitative in nature. You are not getting the data in numbers. You are getting the data in terms of the computer bits and bytes. The other also, this lookalike is possible, right? Not necessarily all the data has to be structured data. There are a number of cases where the data are unstructured in nature. Unstructured does not necessarily mean text. It also does include text, but it is beyond text as well, right? So Hamming distance is something that works precisely with the text data. Let's understand this KNN in much more depth, and I have put more slides in the appendix part for you to make it understand. So how does, say, KNN algorithm work, for instance? So this is the question, like this blue star, is it a part of the red circle or the green squares? That's the question, right? So you are drawing a kind of circle in the sense that you are figuring out the closest ones are all the red circles, and you are saying that, yes, this star is a part of these red circles. So that's how the algorithms work. Now let's dive further deep. So we have got the first basic steps. What are the basic steps? Like first you have to calculate the distance. Distance between what? This one is kind of question that's in question. Is this the part of this or this is the part of this? Which one is this the closest one? So that's how it calculates the distance among the nearest neighbors. Now you're understanding the meaning of the word nearest neighbor. So what are the K means the number. How many? 1. Should I measure with 1, 2, this one and this one, or 3? 1, 2, 3, or these are 1, 2, 3, 4, 5, 6. So what is that is the kind of K. So this is the kind of following basic steps like calculate the distance, find the closest neighbors, and vote for labels. Okay, vote is very simple. Okay, I'm finding that this 3. So that's why it is most likely it has been given in the odd number. A is always the odd, like 3, 5, 7. Which one is having the closest? How many are the closest? So that's the kind of vote. And then we measure it by multiple ways of distance. I have also figured out. You must have, learned these things since I found from your answer that you have done or you have understood cluster analysis. Somebody must have, or some professors must have taught cluster analysis. So these are different kind of distance metric. This you must have done in 11, 12, like Euclidean distance, right? There are different kinds of Manhattan distance, Minkowski distance, Chebyshev distance, cosine similarities. The Hamming one I was telling you about within the words is been used, and formulas also. Not that you have to be, I hate formulas. You need not have a look to these formulas. By the grace, and we're in such an era that most of these formulas have been taken care by the library or the software, whatever you're going to use. So those who are not from the kind of science or computer science background, I find students who have got interest in this area, but not from that science background, don't get your mind bogged down by the formula. It is good to have the knowledge, good to understand the formula, but even if you don't understand, don't worry. Software or a language will take care. Okay, coming back to the k nearest algorithm part. Say for instance, k equals to 1. So if I take the 1, I can find out that this is a part of the class A. So you can see it, right? Class A and class B, red and green. So it's a part of class A. Now, if I find k equals to 3, so I can find out, yeah, these 3 are the closest. If I have to make it the k equals to 3, I'm finding these 3 closest. If I make it k equals to 7, I can find it. These are having the closest. So that's how the k nearest neighbor algorithm works. I hope the logic is clear. The underlying logic of the algorithm, you can explain it to anyone. Hey, I know k nearest algorithm now. You can say that, right? Yes, no?
Yes, sir.
Yeah. Great. That's fair enough for the second class. That's good enough, honestly. I hope it is a yes for everyone. His voice is representative of the class. And feel free to let me know. And honestly, I know if it's a kind of online class, you can just put the laptop on, you can do whatever you want. Of course, you can do those things, but that will be your loss, honestly. Nobody is going to clarify this. I shouldn't say nobody, but it is difficult. It will be difficult for you to understand these concepts in such lucid language. Okay, coming back to what we were discussing. Yeah, we were here. So we discussed k nearest neighbor. Sorry, we were here. We discussed k nearest neighbor. I discussed you about the LSH part. That especially when you have got. I also discussed the Hamming distance, especially LSH when used when you have got the non-quantitative data. Quite possible. Non-structured data. Quite possible. Don't think that all these problems you will get in every industry. You will have all the data in the flat files in CSV format or in Excel format. It doesn't happen like that, right? Life is not that easy, especially for analysts. You will have data in multiple structure, multiple formats. So you have, it's just like a kind of quiver. You understand a quiver? Where all the arrows have been kept, or forget about a quiver. You know about a golf bag where multiple golf clubs have been kept, and you just pick out the right golf club for a shot, figuring out that where I want to place the ball. So it is just like that. You have to keep all your algorithms handy, and you must be you should be a master, right? Okay. To use, given this kind of data, given this kind of objective, I have to use this algorithm. That's the kind of thought process you could develop. That's the thought process is required to be a real great analyst or a thinker in this kind of territory. Otherwise, again, don't get just by the R or Python, because that becomes mechanical. That's required. That's a necessary but not sufficient condition. That's what I want to mention. Okay, now this is something the easiest part, Churn scoring algorithms. By the way, do you want me to take a class on these techniques, kind of hands-on session? I can do that thing. I don't mind. Do you want me to take a hands-on session on any? Are you exposed to this technique? Because if you are already been exposed, I need not again reteach you. But if you don't know how to apply this logistic regression, which are very rudimentary in that way, or decision tree random forest, I can teach you that also. So tell me very frankly, yes, we know or we don't know. You have been taught or you have not been taught.
No, sir.
Not been taught.
Sir,
sir.
the students are marketing, not analytics. They
Yes,
have
no.
chosen analytics
Okay.
as a minor.
Okay, cool. Doesn't matter. Then what I shall do is that maybe next class or whatsoever. Don't worry, because I believe these are all mechanical things. You know how to apply it. I shall teach you. No big deal. No big deal. And you can also study by your end, because nowadays all these, you know, if you want to use R or Python, those who are comfortable in coding, they should use Python and R. Python is very easy. It's just like English language. If you can write in English, you can write in Python. I say it in this way. It's so very easy. R is also easier to just call the library, no big deal. It is not kind of programming in our era. In our era, we have to literally write every line. When you used to code in SAS at our time, you know, even for SAS, and I am a certified SAS programmer, by the way, in our time. And nowadays, it has become so easy, so easy. So you can try your hand, no big deal. But then I can also teach you in a class about how to do these things with taking some real life problem, no big deal. To understand the concept, but that was kind of intentional for me, not to show you the software from the very first day, because you know the story first, let yourself be immersed in the story, then let the software come. Otherwise, it happens, you know, think about some of the physics classes. From the very first day, all these, you know, physics problems start and your mind is out. No, this is not for me, over. No, it is definitely for you. For logical thinking, critical thinking, you need not have a kind of computer science background. So you enjoy the story, other things will follow suit, not a problem. Okay, so that's a good knowledge for me that you are not been exposed, so I should teach you, no big deal. So this part I explained to you yesterday. Like, otherwise, let me ask you a very basic question for me only to understand from where I should start. Do you guys know regression? Yes, no. Regression means not theoretically, not theoretical knowledge, but hands-on. Are you hands-on with regression? Yes, no.
Yes, sir.
Yes, no. Yes, no. Are you hands-on with regression? Yes or no? If I'm audible.
Yes, sir. Basics, we know, sir.
That's good enough. That's good enough. Is that true for everyone? I understand, you know, but because why I'm asking this question, where from I shall start? Shall I start from logistic regression, decision tree, survival, or you want me to start from regression only? That's the question. That's the reason I'm asking. Do all the students know regression, hands-on, can do solve a regression like this? Yes, no? Please tell me, yes, we know regression very well, or no, we are not very sure even about the regression. There can be two answers to binary variable. Nothing in between. Tell me. Why are you shying away? Unless you are not in front of your laptop. That also a probability. I assume all of you are in front of your laptop. That's the least I can expect. Guys, am I audible to you?
Yes,
Yes,
sir, you
sir.
are.
Okay. And you know regression or not? Tell me frankly. Hello?
Yes, sir. I think basics are clear to all of us.
Awesome. Awesome. Very good. So I need not work with the regression. I shall start away logistic decision tree and forest like that. No worries. That will be taken care in one of the classes. Not a big deal. So think of logistic regression is a kind of regression only where you have got a binary dependent variable, which I have shown in yesterday's class, like 0, 1, 0, 1. That's the binary dependent variable. In some situations, not in case of churn, since from the perspective of logistic regression, There are sometimes even multinomial dependent variable also. In such scenarios, we call it multinomial logistic regression. What does that mean? Instead of 0 and 1, so you have got 4 classes, 1, 2, 3, and 4. And you want to classify the customers into any of these 4 groups. So in that time, it is multinomial logistic, but not in case of churn. It's not required. Churn 0, 1 is good. Decision tree like uses the tree graph or mode of decisions and their possible reasons. Say, for example, you create a decision tree like I can show you a beautiful Google graph. I think it was there in Google only. I need not. Decision tree and churn. A simple image you will understand in a minute. Yep. Yeah. So yeah, this is a kind of decision tree. Or which one can I show to you? They're all customer churn decision tree. Or what I can do is that I should show you for an example that would be better. I shall solve it. So customer has not opened an incident past in 9 to 12 months. Yes, no. Customer has not opened in the past 6 to 9 months. Renewed. Customer has 1 or more previous cancellations. Yes, or renewed. Customer has less than 20 total incidents past 18 months. Cancelled or else renewed. That's a kind of decision tree. I hope you are getting right. Can you see my screen? This one, this graph?
Yes, sir.
Yeah, that's pretty simple. Of course, we'll work it out. No big deal. I shall work it out in front of you. That would be even clear to you. But that's how a decision tree in the context of churn works. You got a promotion, customers who have got a promotion, not got a promotion. Then the promotion amount could be say greater than say $50, less than $50. Greater than $50 takes place in a kind of festive season or not a festive season. That's the kind of decision tree you can do. So random forest is nothing but when you have got multiple decision trees and multiple decision spreads are being ensembled together, you create a random forest. Have you done your quick homework? I told you about to read about ensembles, bagging, boosting, extreme gradient boosting. So I'm not asking about whether you have done it or not, but please do read by yourself. Of course, I shall going to teach you maybe if time permits, you can go for hands-on sessions, but read by yourself. Similarly, support vector machines like churn or not churn through a hyperplane, we can figure out by a kind of support vector machines. This one I started discussing yesterday about the survival analysis. So what we can do is here is that besides the churn, not churn, we can also have the duration in terms of the number of days or number of months, and then we can predict time to churn for a segment of customers. And then not only for one segment, we can compare time to churn between 2 or multiple segments. That's what, as was discussing in the Lenovo context or any laptop context for that matter. If we can create the segments first and then we can do the time to churn, we can compare them. And then assess the relationship of the covariables to time to churn, such as does price increase, customer satisfaction, inferior product quality influence churn time customers. That means what? There are different independent variables. There are different factors. How do they leave an impact on the time to churn? So if there is a kind of price increase, if the customer gets dissatisfied, or with the product quality is inferior, does that leave an impact on the time to churn? And then we do it survival analysis where we have got, as I mentioned, one dependent variable is that 0, 1, and the second dependent variable is the duration. We also take into consideration the hazard function, again a very important term, which is the conditional probability that the event will occur within a small time interval after t, given that it has not occurred. And we do it, just I'm throwing some names, it is good to know these things, we will work it out. So I'm getting the theory part clear. We will do the practical maybe next class or sometime. Like you must be knowing about the different terms like exponential, Weibull, Cox regression, Kaplan-Meier. What is that thing? The hazard function. That is the conditional probability that the event will occur within a small time interval, say in the next 3 months or so. Then I have to figure out that whether there is a kind of parametric estimate or not. That means parametric. Do you know parametric, non-parametric, by the way? What is parametric? What is non-parametric? Yes, no?
No, sir.
Okay. So parametric means simple when it follows a kind of normal distribution. You know a normal distribution, right? You know
Yes,
normal.
sir.
Perfect.
Yes, sir.
Yeah, that's it's no big deal. You have to just test the normality. You know how to test the normality? Who can tell me? What are the ways to test the normality? How can I figure out it's normal distribution or not? Have you heard about something called Kolmogorov-Smirnov test, Shapiro-Wilks test? No worries.
No, sir.
No worries. Uh, One thing I can tell you, and tell me something. How many of you just say yes, 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 yes? No need to chat. Just tell me. How many of you are coming from statistics background? Any of you? Two, three, four, five? If not, maybe a very small number. And I also assume that you all want to establish a career in analytics. So, of course, I shall see this class. I am going to say a lot of things. You have to take the cues from this class and do your homework. So if I mention these names in the class, you must do your homework. Okay. Swabul has been explained in the class. What is that thing? How does that take place? How can I actually do it? Or Cox regression has been told in the class. How can I do it? So do a lot of homework because you have to actually take some extra effort, give some extra effort, right? Because you are not from statistics analytics background. So I shall do these things, but keep in mind what is exponential is kind of parametric. When you have got a kind of normal distribution, for hazard function increasing or decreasing over time is constant, is exponential, increasing, decreasing is weighable. When you have got semi-parametric, it is Cox, and non-parametric is Kaplan-Meier. That's how survival functions work. Now let's come to the suite of deep learning neural networks. This one is about this again for the time prediction only. We can apply the deep learning. You got a chance to go through it yesterday. I have given you some exposure and also kind of homework to go through it. So I assume you have gone through it, and if not, let me quickly walk you through. These were the different, neural network I was discussing. As you can see from this sign, there is a kind of loop within these memory cells. This is the kind of long short-term memory or the recurrent neural network. And that's something of very important, very much important, the churn analytics concept. Why? Because you will get a kind of time series data across that time where how the customer behaved. And that's why it's important. Now, this is the kind of loop our recurrent neural network is having. Like it is having the input data, it is having a loop, and then it is the output. Now, if you just, don't get bogged down by the word loop, loop is nothing but if you test a kind of series of events, an unrolled recurrent neural network. So when you have in multiple series, it is a kind of unrolled one. That's the meaning of the word loop. That's how we can break down a loop. And that's how, LSTM is nothing but another, more sophisticated version of recurrent neural network. What are the most sophisticated versions? Like it has got the different kinds of gate. First of all, it's the kind of state. So it's there in the slide. I hate reading out the slide. I assumed, have you all gone through the slides? If you have any question, I can ask that because reading out the slide is pathetic. Have you gone through the slide by yourself? Or did some homework from Google or other places? Okay, folks, make it a point. Make it a point. Please do your homeworks. What I'm saying to you, it really has a value. It don't take it, just a kind of formal requirement. It really is required because you don't have a statistics background, and analytics has got a lot of statistics. So you have to come from here to here, and not everything can be taught in 1 hour 15 minutes. I shall give you multiple things, and then you have to do your homework, come back to the class, share your thoughts, ask me questions, get them clarified, make it more interactive. And then you will have a lot of fun, right? Otherwise, lecture is so boring. So what happens is that there is a kind of cell state which store the information. It goes from forget gate, update gate, output gate. What is this forget gate? It is a cell state that stores the information. It decides what information need to keep and what information needs to be thrown away from the cell state. Not that every information is required, right? So depending on the reinforcement, you need not keep every information. And there are certain important information which you need to, new information needs to store in the cell state. Say, for example, this kind of pandemic happened, the COVID happened across the globe, and you have got a time series data. For example, I'm working on a project about sales forecasting of the cars, automobiles. Now, I cannot just do a kind of time series analysis because that will never fit, because such kind of pandemic never happened at past, where the automobile sales almost came down to zero. So in such scenarios, you cannot just depend on the traditional time series. So you have to depend on the more augmented one. I shall discuss this thing again in length and breadth when I shall discuss sales forecasting. But to make the matter very simple, keep in mind is that LSTM has the power to remember what is important and to forget what is not important. And that's the beauty of LSTM, and that's what makes the model accuracy, the predictive power, at a much higher level. And that's what I'm going to show you in the subsequent slides here. So yeah, we were here. So this is a kind of ensemble where I have got the DNN here, kind of static feature inputs are from the DNN, and then the time series input coming at the kind of LSTM. Why I'm showing you this slide? It's very important to get your mind conversant with the idea of an ensemble. What does an ensemble means? Where you are combining two models. How you are getting combined, we will come all those things if time permits, of you have got the right capacity will come. But at least get the concept of ensemble clear. How these things happen when you are having two models are actually merged to a merged layer, and then you are developing an output. It happens. It is required in many of the scenarios where you are merging couple of models together. Even more than two also there. I'm not confusing you at this stage, but at least two. Even I have given another example in the appendix. Yeah, this is another example, right? So it's a kind of classic ensemble, like you are having LSTM, long short-term memory, and gated recurring unit. These two are different variants of recurrent neural network. You are actually creating an ensemble and you are developing the output. Don't worry, don't get confused by this kind of image. It's fine. But at least this concept is clear that yes, at least your takeaway from this slide is yes, models can be ensembled, models can be combined together. And models can be combined in multiple ways. And that's where I'm intentionally taking the second class, not any kind of mathematics, but at least some exposure about how they can be combined. Now, as of now, you must have thought or you must have heard about only one model, but it's not like that. So when we are doing which customers are worth retaining, so it's a kind of time series data about the customers' recency, frequency, purchase. We discussed this thing yesterday, RFM part. But then I have got the time series data. There are multiple ways. To analyze time series data. It can be a traditional time series. It can be a tree-based data. It can be a deep learning. That means what? Traditional time series is statistics. Tree-based is machine learning. Third one is LSTM, is a deep learning. And in reality, we apply all the techniques. We apply time series. We apply machine learning. We apply deep learning, and then we compare across the models. I'm repeatedly, hammering on this concept of model comparison, which we'll discuss, but at least you understand now. And I shall discuss these things. I shall like to show you that how we compare across the models in my sales forecasting class, because this is typically been used for the sales forecasting, but will be equally used for the customers lifetime value prediction. So how I'm combining here? Just look at the how I've shown the pictures. Very simple. Couple of brick slabs are been stacked one after the other. Same thing can be done. Input data is there. One model, even if you don't understand, I already explained you what is LSTM, right? So one LSTM layer is there, another LSTM layer. Now we are merging them and developing the output. That's how the models can be stacked together. And models can literally be, that's how multivariable stacked MLSTM. So multivariable stack. So what happens is that when you're having multiple variables that are leaving an impact on the time series data. So after the input layer, there are two LSTM layers stacked together. You can see the two LSTM layers stacked together. This is the input layer. And the first LSTM layer produces sequence vectors, which will be used as the input of the subsequent LSTM layer. So that's how one layer leaves an input to the next layer. That's how models can be combined. Are you all with me? Are you all with me? You are all getting what I'm saying? I'm making it
Yes, sir.
as lucid as possible. I'm just
Yes.
telling the complex concepts in English stories, simple English language.
Yes, sir.
Very nice. I
Sir, I
appreciate.
do have one
Just
doubt,
be
sir.
with me. Listen to the English story. Mathematics will come slow by slow. But if I start with the mathematics data formula, mind will be completely out. No, this is not for me. And I don't want a
Sir.
single student to say. A question? Somebody has a question?
Yes, sir. Sir, during stacking, how do we come to know that which stack or which data will be kept over each other? Like we are getting different data, right? We are
Mhm.
creating a stacks of layer. So how should we know that which
Just a
layer
minute.
will come?
Just a minute. What do you mean by different data? What do you mean by that?
Different data means suppose during stacking, data
Let me
one.
clarify. Let me clarify. Because there
Okay.
is some problem in the question. There won't be different data. First of all, currently what we are doing, this is typically being used for the time series data. What do I mean by time series data? When there is one series, not different data. Say cells across multiple points of time. Why it is important here? Customers purchase across the different time periods. So you don't have different data. You have got say total purchase. Say rupees 2000 in month of last month was say July, then 1500, 5000 like that. So you have got this series, this data is coming as input. This is processing that what could be the next level data. This is further refining in that way. It is flowing through the channel. You don't have multiple data at this stage. That will be there. We'll discuss, but not here. Am I clear?
Sure, sir.
May I know your name, please?
Sure.
Thank you so much for asking this question. And honestly, I am getting a few names only, which is very good. I appreciate all the students, but you have been more happy if I can, remember all the 44 names just by listening to you when you will ask me these questions. Okay, now some more interesting things, and just listen is the kind of film, a good film or a kind of good concert or a good storytelling session. So these are kind of bidirectional LSTM. So one way, this is the forward, and this is the backward. And what is happening in the process? In this forward, this LSTM is here. This is the kind of sigmoid function, and whatever is the the output of this LSTM through a sigmoid function, this gets the input to this LSTM, and then it goes. So that's why it is the forward and this is the backward. So what happens is that these are all your independent variables. Xt minus 1, the time series. These are all the timestamps. T is the timestamp. Xt minus 1, xt, and xt plus 1 is timestamp. So having the LSTM here, and this is how they combine to a sigmoid function. It predicts, it predicts, it predicts. That's how the forward and backward happens. And if you come here, this is even, again, don't get bogged down. I'm just showing you, I know it is a bit complex, but as a kind of English story, you understand how things are happening. So this is again the timestamps data, the spatial time series. Spatial means the space, and temporal means space and time. Spatial temporal means space and time. So spatial time series inputs. You are having these things. If you want hidden missing values, you can mask to the hidden missing values, and they go through this layer. This is the part. This is what I discussed just now. Through this layer, and then there is bidirectional further learning using the BDLSTM, bidirectional LSTM. Then there is another LSTM. Then they're all been stacked, and then the final prediction is been done. Not that you have to do these things. You need not do these things at this stage, but at least get yourself exposed. Okay, things happen in this way. I never knew that. I had only one model. I never heard about stack model. I never heard about bidirectional. That's how things happen in today's world. And let me tell you why it happens in today's world. That's the question you should have asked. Why? Why? Here is the answer of the why. So since you have done regression, you know R squared is the measure of the predictability power, right? So this is the kind of, I've taken from our research paper, a multi-variable stacked long short-term memory network for wind speed forecasting. Now, if you look here, for the same data, multiple linear regression is giving you a 93.7% accuracy. Lasso and Reach, you must be knowing, these are the different forms of linear regression, typically been used when there is a lot of collinearity in the multicollinearity data you have there. Like independent variables have got a lot of collinearity or a lot of correlations among themselves. That is the multicollinear data. So you are getting 94.1 in Lasso. For Reach, it is even far less, 75%. In LSTM, which is a kind of deep learning, you are getting 99.6. In the stack LSTM, you are getting 99.9. So are you understanding why it is important? Why it is important to go beyond the realm of regression and dive deep into the realm of deep learning? Am I clear, guys? What I'm saying? Am I making sense?
Yes, sir. You can understand. Yes, sir.
All of you are with me? Or
Yes, sir.
thoughts? Very nice. Very nice. I understand what I'm saying, that I'm of course not working you through, because you are definitely not in a state in the second class to appreciate the entire thing, understand the entire thing, but at least high level, a film is going on, you are getting some idea. Okay, so this is how the stories go, this is how the characters behave in this film. So that's good enough for the second class. So with that, let's come to the third step, which of course I shall, discuss again later. But let me give you some idea how part hold on for the next class, and there is a reason. But let me tell you what this step 3 is. If you remember, let me also browse you back. I'm coming from here. I'm coming from this framework. This is the step 2. This is for this reason only. For predicting CLTV only, I was discussing all these bidirectional HTML, LSTM, and then the multi-stack LSTM for this part. Now from here, I am doing some justice to this step 3. Okay, so please remember, this is the backbone. Are you understanding? This is the backbone. This is the backbone. If this is not done rightly, if this is not been chalked out, if the solution is not been designed, that's how we call in the industry, who is the solution design guy, because that's the most important thing. Why? It's just like a radar of a ship. If the radar of a ship is not been set on the right direction, then no matter what all the laborers in a ship do, they will end up in a completely wrong direction. So this is the most important part, the radar, the fundamental, the backbone of any research or analytics program, the solution design. The remaining part is execution. Execution is on a lower capability job, but this is the kind of thinking job. Okay, so which customer decisions can be prevented, and differential discounts through promotion response modeling we can do. What does that mean? What does differential discounts mean? Even if you don't know, what does come to your mind? What does differential discount mean? And without reading the slide, even better if you can do it. Go ahead, tell me. What does differential discount mean? What comes to your mind? You know the word differential, you know the word discount, right? Guys, please be responsive.
So sometimes what we do is,
Your name first.
Sir Aishwarya.
Yes. Please go ahead.
So we do discounting. For discounting, we use a different discounting method for different customers who pays more.
Absolutely. Absolutely.
Or we do less discounting for those who actually not our customers, or who buys the product less. Is it? I'm not sure sir,
No,
exactly.
no, it is not correct actually. Anyway, but your concept is correct. Your concept is correct. The example was not correct, but concept is correct. Concept is that not that one size doesn't fit all. In one word, one size doesn't fit all. Everybody 10% discount, everybody 15% discount, everybody 20% discount. That's stupid actually. Uh, there are a number of reasons to it. Why I'm telling for the next class, because next class is customer acquisition. What I'm going to discuss is segmentation, targeting, and this is the part of target marketing. But I shall give you an overview, but I shall discuss this in the concept of, there are two concepts actually, and please study beforehand. Huh? Tomorrow, please come by studying two things, the homework again. For target marketing, I'm going to discuss two things. One is propensity modeling, number two, uplift modeling. I repeat once again, tomorrow is the class for customer acquisition. I'm going to discuss, for the next two classes, I'm going to discuss segmentation, targeting, and recommendation engine. Even if you don't study recommendation by yourself, that may be a bit critical, which I'm going to discuss. But target marketing is not that difficult. So please study two concepts, propensity modeling, uplift modeling. Now let me discuss what differential discount is. As I told you, a very basic predicament, fundamental thing is that one size doesn't fit all. Why? Number one, whether I require that much of discount or not. Say if I in any case purchase, and if you offer me 20% discount, it's your loss, right? That's absolutely your loss. You need not give me that discount. On the other hand, somebody is very unlikely to purchase, and if you really give a very attractive discount, that customer, probability of the customer going to purchase will go high significantly. So that's the meaning of the differential discounts, which I shall discuss in detail anyway. To determine which discounts obtain the optimal response from each customer. So that's a very, very critical question. And to understand it is, in fact, I have put the very large concept in a few words. Try to meditate on this line. Like, what discount should I give to create the optimal response? It's just like, response and stimulus. Say you have done in your physics lab, maybe in your +2 or graduation in engineering, that how much current should I give, or if I not give the current, the resistance and the heat generated. So how much resistance is generating how much of heat? The same thing here. How much discount I shall give to generate the optimal response from each customer, and offer the minimal discount through email to customers who are already deemed likely to buy. If I'm already likely to buy, then I need not give me 20% discount. Even without a discount, or 2%, 5% is good enough. And offer large discounts for customers who are likely to buy. So how much to give to whom? So that we do by the promotion response modeling. And that's a kind of propensity modeling only, which we will discuss in the next class. Last but not the least is always how to present. You have done a long story. Oh my God, I have learned so many things. You are going to a customer, you are presenting that, hey, I'm going to do k-nearest neighbor, I'm going to do LSH, I'm going to do holistic regression, recently, random forest, support vector management, survival analysis, deep learning solution suite, which includes so many deep learning techniques, survival analysis, so many techniques. Do you think customer will be impressed? Customer will say, thank you so much. You know a lot. I appreciate. Keep your knowledge to yourself. I don't require such bombastic things. This is exactly the thing customer will say. That means what? What does customer want? Customer is not bothered about what machine learning, deep learning techniques you are going to use. That doesn't matter. Customer wants a very clean, neat, easy to use interface. All your high fund algorithms you keep in the backend, such that what is very important, such that whatever is coming in the front end is absolutely accurate, true, to the best. So that's what which I mentioned here, a kind of smart customer dashboard, or that's what a kind of visualization, that's what a storytelling is. So it can have some very basic information, like if I just type through a search like Hester, so Hester Stewart, full name will come, age, gender, state, Colorado, and then subscribe, particular date, current offer I have given medium, previous offer was medium trial, last paid was this date, referred, yes, he has been referred. And then the churn dashboards are there, like his high risk customers, like 78%. Why he is high risk, like competitor pricing. If the customer goes to competitor, potential loss is this much. Recommend offer, small. So it may look very simple. It may look very simple, but under each of these algorithms, so potential loss, is entire customer lifetime value. That algorithm is there. So all this LST, multi-stack, whatever we learned, all the algorithms are stacked at the back end. But customer wants a very simple thing in the front end. Very simple means very easy to understand, easy to appreciate, user friendly. And that's the kind of dashboard. So if you know the concept, by the way, next best offer and the next promoter score is again very important. I've not shown it here. Again, a very important part is the next promoter score, net promoter score, NPS. That means how likely the customer is to recommend. So get yourself acquainted with multiple dashboards, visualizations. Again, separate classes may be allocated for data visualizations. That is fine. But even if those things are not there, learning Tableau is the easiest task in the world. Easiest task is learning Tableau. It doesn't require any programming, and student license is free, I guess. Tableau student license, even if it is not free, you can install it for 14 days in your laptop. You can just play with it, child's play. To just drag and drop. Tableau interface is the easiest in the world, and that's why it's the costliest among all the most expensive among all the visualization software. So get yourself hands-on. While your programming backend is important, you should have some idea about the front end as well. So see the different kind of software. You go through the Google, go through different websites, how they are presenting, say the customer segmentation, target marketing, recommendation engine, churn dashboard. Say for example, you see the Amazon or you see Flipkart. Customer who has purchased product X has also purchased product B. Forget about Flipkart, Amazon, even the YouTube, which you always use, or even the Netflix or Amazon Prime. All your favorite movies are being showcased. You don't know that such complex recommendation engine is running at the back end. They are doing segmentation, they are doing running recommendation engine, but look at the user interface. That's lovely. You will not ever realize that so many engines, so many algorithms are actually running at the back end. So that's the beauty of a kind of user interface, and that's why I have intentionally kept this slide, so you will have some visibility, some perspective would be developed about how the front end should look like. Front end does matter, because customers are, especially in such scenario where the customer is in a B2C space, where the other users will come. Customers developing an app, and the customers like you and me, the layman customers will come. They can't they can't play in a complex environment. So for them especially, this front end is extremely important. Not that you need to know the technology, I'm not saying that thing. You can always try your hand in Tableau, I recommended that, but not that React Native software or all the mobile app development software you need not understand at this stage. But at least the importance, designing. Say if a client asks you, hey, how do you think our front end should look like? So if you have got 100 snapshots in your mind, you can always mix and combine and then come out with your own thoughts very easily in a couple of seconds. Oh, then you should have this risk meter here, like a speedometer. You can have a risk meter. You can have this information. Like say for example, a risk they have mentioned high. I could use a beautiful risk meter here, chart risk meter, like a speedometer of your bike or car, and then what all factors you can actually change the different factors, and then the risk meter will 78% can move to 80% or even come down to 70% like that. So that's the kind of beautiful dashboard you can develop. That's the beauty of a dashboard. So start thinking from that perspective as well, how I can better present my algorithms to the customers. Customer don't care about your raw algorithms, raw codes. That has to be packaged nicely through an interface. So think from that perspective as well. Am I clear, guys? I'm almost up the time. I just looked at the watch. Guys, am I clear?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
So perfect. Feel free to drop me mails if you have any questions. You can ask me the questions right away also, though I'm just, it's 10:15 sharp. Drop me mail, and tomorrow again we are meeting. Just be on time. Tomorrow I'm going to discuss next two classes: customer acquisition, segmentation, targeting, recommendation engine. I'm going to discuss. So get yourself prepared. Do some kind of background study, background work, self-study. Ask me questions. That's very important. Be interactive in the class, and we'll have a wonderful session then. And do study propensity modeling, uplift modeling, so that you can better engage in the class. Simple. Okay, guys. All the best. Have a great day.
Thank you, sir.
Welcome. Bye-bye.
Thank you, sir.